Good day, everyone. So it's your favorite mathematics and physics tutor, Mr. Shebu. So we are back here with another video on physics, which is we are looking at a topic which is surface tension. Surface tension. Surface tension. All right. So I know most of us have dealt with this topic before, but today we're just going to give it. We're going to open your eyes to see more things on this topic. So let's go. Surface tension. Now there are two words you need to take note of here. We have surface and we have tension, right? Surface simply implies probably the overlook of an object, right? Meaning its face, as the name implies. And then tension is very much synonymous to force. Alright? And when you bring the two words together, what that simply is the force that acts along a surface. So let's put it in context of fluid. So if I want to write this will be surface tension in fluids. So when we say fluids are gases and liquids. Gases and liquids. So now let's quickly move on. Now surface tension in fluids, alright? Now surface tension, like I explained to us, is the force that acts along the surface of a liquid that causes the liquid to act like an elastic skin. Let me recap that again. I said surface tension is the force that acts along the surface of a liquid that causes the liquid to act like an elastic what? Skin. Now, let me give an instance. If you have a tap, for instance, alright, when you put on a tap, when water gushes out from the tap, right, and then you close the tap. Now, most times you will always notice that there are drops of water hanging around the surface of the tap. Now, why is that? I want to ask yourself that, okay, why is it that these drops of water are not, falling down? Why are they hanging around or hanging, alright, at the surface of the tap? And that is by the work of, or due to what? Surface tension. So surface tension basically acts like a covering, right? It acts like a veil that helps to cover the liquid, all right, to prevent the liquid or to prevent substances from getting into the liquid. Now let me give you a practical example, right? In case of washing, right, we have hard water and we have soft water, right? Now in case of washing, whenever you want to take, if you have a clean water, all right, and let's say this clean water, this water is a hard water. When you say hard water is as a result of the high content of carbon. It's a high content of carbon. So when you have a hard water, right, and probably you want to use that water to do some chores, you want to wash, right? Most times, some water, which is hard water, does not lather with soap. And the reason why that happens is because of what? Surface tension. So surface tension is like a skin that covers the surface of a liquid, that prevents, or that acts like a shield, exactly, all right, that prevents substances from getting into the liquid. So that's the best way I can put it across to us. Okay, now we have applications of surface tension, of which I will get into, but for now I just want to have the basic idea that surface tension in fluids is like a skin, all right, or a shield that hovers or that is covering the face of a liquid, alright? So that is what surface tension is. Now, surface tension has its application, it has advantages rather, and it also has its disadvantages. So let's list out some of its advantages, right? Now, surface tension is used in umbrellas. It's used in umbrellas. Now, in an umbrella, you have a material, right? You have a material that prevents water from seeping through such material, right? Now, that material uses the concept of surface tension, uses the concept of surface tension. So the material acts like a skin, all right, that makes sure water doesn't seep through the umbrella, all right? And such skin too can also, that's basically the point. So there is a skin or the material in the umbrella that ensures that the water droplets does not seep through the umbrella. Alright. Now let's list some of the applications of this surface tension. Alright, let's list some of the applications of surface tension. We also have applications of surface tension. We have lots of them actually. Yeah, I've mentioned the one of when you have a water and you want soap to lather with the water, right? Most times it doesn't lather because of the surface tension on the liquid. So that's basically what we mean by surface tension. It is a force that acts along the surface of a fluid or a liquid or a gas or a fluid. Now, let's quickly move on to another concept which is still under surface tension, right? We want to look at capillarity. We want to look at capillarity. What is capillarity? Now, capillarity is simply the tendency of a fluid or a liquid to rise and fall in a narrow tube. It's the tendency of a liquid to rise or fall in a narrow tube. So when you have 3 test tubes, for instance, and then you fill each of them with different liquids. Are you with me? So let's say this one is filled with clean water. This is filled with soap water. This is filled with or to make it more practical, or for you to understand it better, you have 3 test tubes. So you have, this is clean water, this is soap water, and this is, let's say, mercury. Now, capillarity is the tendency of a liquid to rise or fall in a narrow tube. Now we have these 3 narrow tubes. So like I said, capillarity is the tendency of a liquid to rise or fall in a narrow tube. So that tells you that some liquid rise faster than the other, alright, while some fall faster than the other. So each liquids have different capillarities. Now, we have to talk about adhesion and cohesion. Adhesion simply is the force of, adhesion, or let's start with cohesion. Cohesion is the force of attraction between 2 molecules of the same kind. Cohesion is the force of attraction between 2 molecules of the same kind. Now, what does this mean? E.g., for instance, molecules of water. Now, if you have 2 molecules of water, there is always a force of attraction, alright, between these molecules, alright, and that goes for every other substance or every other liquid. So there is always a force of attraction between these molecules. That's what we mean by force of, or that's what we mean by cohesion. And now, adhesion. What is adhesion? Adhesion is the force of attraction between 2 molecules of different kinds. So you have molecules of water and molecules of glass, for instance. So this is glass, this is water, this is water, and this is also water. So the force of attraction between these 2 is what we call cohesion, because they are of the same kind. Molecules of water, molecules of water. While adhesion is the force of attraction between 2 molecules of different kinds. This is molecule of glass, molecule of water. So that tells you that water rises faster in narrow tubes. Why? Because the adhesion between water molecules and glass molecules is very, very strong. Alright? So that is what we mean by capillarity and we mean by adhesion and cohesion. Alright? So also we have other things we have to look at. We have viscosity. We're going to talk about viscosity upthrust, and so on. There are a lot of concepts under this, right? But for now, this is where we're going to end this video. Alright, please make sure you study through, alright, and you can as well backward this to see the areas you are not really clear on. So thank you so much for watching. Hope to see you in the next video.